Hello developers, welcome to day 26. Woo! We are just 4 days away, let's hold tight. Today we have another opportunity to tackle challenges and deepen our understanding of JavaScript concepts. Let's dive in and make the most out of this learning journey. Today's challenge says, given a multinational array and a depth n, return a flattened version of that array. So today we are supposed to flatten an nested array. So this is a common challenge in most tech interviews. So let us continue reading the challenge. It continues and says that a multidimensional array is a recursive data structure that contains integers or other multidimensional arrays. A flattened array is a version of that array with some or all of the subarrays removed and replaced with the actual elements in that subarray. This flattening operation should only be done if the current depth of nesting is less than n. The depth of the elements in the first array are considered to be 0. So you're told that the depth is considered to be 0 in the first array. So okay, then you're asked to solve it without using the inbuilt Array.flat method. So you can just look at example 1. So example 1, there is this arrays. So this first here, these are index are considered to be to have a depth of 0. So depth 0, this is individual, this 1, 2, then this one will be treated as one element at depth 0. Then this one also as one element, then this one as one element, like that. But if you notice, this one has a depth of 1 because it's an element, and also it's inside it has other elements. And you can see this, it goes even an extra layer deep because it is an element which has inside other elements inside it, and also other elements inside it have also another element. So that is 2 levels deep. And then this example, I'm told that the depth should be 0. That means you're supposed to flatten this array with depth 0, and that array will just remain the same because I'm told that depth 0 is the way it is. At depth 0, this one is treated as one element, so this one will just be placed there as is. So let's look at example 2 to see the difference. So example 2, now you're told that the depth should be 1. So these ones are at depth 0. This one is 0, but it's inside just elements. So these ones 4, 5, and 6 have the depth of 1. So you're told to flatten with the depth of 1. So this 4, 5, and 6 will be individual elements like that. And also this element here, each one of each, like 7 and 8, will be individual elements. But this 9, 10, and 11, since itself also is an array, and we're just told the depth should be 1, and this is depth 2, we'll just place it the way it is, like that. And this one, since it's depth 1, it will be flattened to be 13, 14, and 15. So that's how I'm supposed to solve this challenge. And you can see this here, it goes even 2 levels deep, so depth 2. This one here will be depth 1, so it will be flattened. This one is also depth 1, so it will be flattened. This one here, 7, 8, and 12 are depth 1, it will be flattened. Then this one, 9, 10, and 11, they are depth 2. And also them, they'll be flattened because now I told the value of n is 2. So that means that these ones are depth 1, also them will be flattened. So every array here will be flattened, and the result array will just be array of depth 0. I believe you are getting the flow. So that is the challenge. Then you're told that the constraints is that the count of numbers in the array should be between 0 and 10 power 5. Then the count of subarrays in the array provided should be between 0 and 10 power 5 also. Then the maximum depth is less than or equal to 1000. And each number in the array is between negative 1000 and 1000. And the value of n is between 0 and 1000. So that is the challenge. Let us go to the solution. To solve this challenge, I'll create a function. I'll call it flat, and I'll use the anonymous function syntax. You'll notice that this is my favorite syntax of functions. And this function is supposed to take an array and depth n. So there are 2 ways of solving this. There is using the recursion, or you can imitate recursion using a data structure like stack. But I prefer using the recursion solution because I think it's efficient. So I'll just use the recursion. So I'll create another function here. It will be my helper function. I'll just call it helper. So this This helper function will be helping with the recursion. So at the end of the day, I just want to return the results that will be returned by this helper. So I'll just return helper like that. I missed the spelling. There's an R here. Okay. And to make our lives even easier, I'll have a result declared outside the helper function. So I'll just declare my result up here, where we'll be pushing our results. And this result should be returned by this helper function. So I'll just return the result there. Okay, this is where we'll be pushing the resulting array there. So this helper function will be keeping track of the array. So we'll pass here the array, and we'll be keeping track of the array, not the actual index, because sometimes you're given a single array that is not nested. So if it's not nested, we just loop through that array. So you can just start with that test case first. So if array is not nested, we loop through that array. So let me just use the for of. So for value of array. So if it's not nested, what I'll just do, I'll just push the results into this result array. So I'll just say results dot push, and I'll push the value. But this, I should only push the value if, let us look at this example here. I should only push the value if this one is not an array. So if it's an array, I don't want to push the value and to flatten it. So I can have an if condition here to check if the value is an array or not. So I can just say if the value, and to check if a value is an array, you can use type of, and you know that array are of type of object. We've already discussed that a lot of times. So I'll just say type if type of value, if type of value is equals to, I'll put triple equals, is equals to an object. So if this type of value is equals to an object, what I want to do, I'll just call I'll use the recursion. I'll just call this helper function again. But this time, I'll call this helper function with that value, because I know this value is an array. I think that is clear. But the challenge says you should not only push, you should not only flatten if it's an array. There's another condition. It says that the depth should also be less than n. So I can put here an and. I can say and if the type is an array and also the depth. So this helper function should also check in a depth. So I can just call it depth like that. So I'll check if the value is an array and also the depth is less than n. So this is the condition where I'll be calling my helper function. So if the item that is reached is an array and the depth is less than n, I'll just call my helper function. Then I've seen that helper function has to be called with the array and the depth. So I can call this with the, but I'll just have to increment the depth. So I'll just increment the depth with 1, so that if it comes here, this should not be true and it will just push. So I'll have to put an else statement here. So else, I have to push the array to the results if it's just flat. Okay, I believe this is the solution. And this helper function, when you call it, I'll first call it with the array that is provided, and the initial value of depth will be 0. Okay, that is the initial value of depth, and you're told there in the challenge. You can just check the challenge. That was the initial value that is provided. So yeah, you can just try this solution with any example. Let me try the example 1. So expect this example 1. Where is it? Just copy it here till there. Just copy that. Paste it there. Soft wrap. I'll just declare this as a const. It ends here. Then this, I'll just say also const that. Okay. Then if I call my function flat, so I'll just call flat. I'll call flat with this array r and depth n. Then I want to log this result. So I'll just surround it with console.log like that. So I expect the results to be the same array, because we've already discussed why it will be just be the same array. Because the depth is 0 and this condition here, depth is not less than n, will not be true. So this helper function will not be recalled. It will just call this else. That's why you see the array is just the same. That was example 1. So the example 2 is the interesting part. So I'll just copy this example 2. I think it's the same array, but I'll just copy it. Don't want to assume. Then the depth, the n is 1, so I'll just change the n to 1. So I expect now this to be flattened because this has a depth of 1, should be flattened. And also this 7 and 8 has a depth of 1, should be flattened. But this 9 and 10, they have a depth of 2. 9, 10 and 11, they have a depth of 2. They should not be flattened. And this 12 should be flattened, then 13, 14, 15 should be also flattened. This is the expected output here. So let me save this and run it again to see if I'll get that output. Fingers crossed. And you can see indeed in the terminal I got this expected output. That means that our code is just working fine. And maybe I can just summarize the example 3. So example 3 is the last example here. So I just copy that and paste it here. Then the value of n is 2. The depth should be 2. So I'll just run this code and expect it to be completely flat with a depth of 0. And indeed I got a completely flat array with depth 0. That means that our code is working because it passed all the 3 test cases. So see you in the next video, and if you haven't subscribed to our channel, kindly subscribe and comment the video. See you in the next challenge. Peace out.